My name is Paul Ramsey. I work for Boundless, the open source geospatial company, and I'm a developer of the PostGIS open source spatial database. Well, in mixed company, I describe myself as a technologist because I'm not just a computer programmer. I'm a generalist, an integrator. I like to put things together that haven't been put together before. I'm a system builder. And I'm guessing that in a room full of FME users drawn from around the world, that might be a common description. Because the FME is a great tool for integrators and systems builders. It's systems glue. It papers over the ugly cracks and gaps that inevitably form when you try to jam two systems together. So I'm going to be talking today about my experience with systems building and learning new technology and how the FME has fit into that journey. Actually, FME was one of two geospatial technologies I learned, the very first geospatial technologies I learned. The first was SAFE, Spatial Archive Interchange Format, and the second was FME, because you need FME to work with SAFE. So way back in 2000, before the first tech crash, I visited the CeBIT conference in Hanover, Germany. Now, CeBIT it's so big, it's so vast, that Hanover doesn't actually have enough hotel rooms to hold all the visitors. So over the years, they developed a system of billeting. You go to the tourist center when you arrive, and you get matched with a local resident who can rent you a room. I got matched with Manfred, who is a German veterinary student in his last year of studying. According to him, and I never verified this, rather than being tested on material progressively during his program of studies, his veterinary program tested students on everything they learned all at once in the final exams. So he was spending a couple months doing nothing but learning his couple years worth of material for his upcoming pass-fail exams. So he was pretty stressed out. In the evening, after a hard day of walking around the conference, I'd ask, "What did you do that day?" And he'd say, "Learnings. I had to do many learnings today." And that phrase has stayed with me for a long time. You have to do your learnings, many learnings. Because our learnings define the boundaries of what we can conceive of as possible. The way we choose to solve problems is usually dictated by the tools we already understand. So the most important decisions we can make, or can get made for us, as knowledge professionals, is what tools to learn. Good tools expand our horizons. They gently introduce us to new concepts, new ways of solving problems. There's usually multiple ways of solving a problem with a good tool. And you can usually see the gears turning inside a good tool. The FME is a good tool. I have a lot of affection for the FME, perhaps more than you'd expect from some rabid open source guy. The reason I have so much affection for FME is that it was one of the first tools I learned at the start of my geospatial career. So it affected how I look at problems and their solutions, and it gave me lots of opportunities for learnings. The first thing FME taught me was that data is not a solid. Because when you look at data through the lens of, say, operational data maintenance, it looks a lot like a solid. It's a big mass, and you chip away at it one little bit at a time, make incremental changes, add a record, edit a shape, modify a record. It doesn't change very fast, and big changes take a lot of work. But when you look at the data through the lens of the FME, you learn that data is not a solid. It's a liquid. You don't chip away at it a record at a time. You pour it in batch from receptacle to receptacle, changing the shape of it on the way from round holes to square holes and back again. When you understand that data is a liquid, your definitions of what a big change or what a lot of work, your definitions change. The bounds of what you understand is possible expand. Data is a liquid. That's a great learning I got early on from FME. The second important thing FME taught me was that it should be easy to integrate different technology parts. Good tools are easy to integrate. And if they're hard to integrate, it's not your fault. It's the tool's fault. Don't blame yourself. So when I started with FME, this was the public face of the company, right? There was no graphical workbench. The way you made FME go was to write mapping files. You describe your data transformation, then you invoke the engine to run it. It's called has a name, actually. It's called a declarative programming model. Describe your transformation in a mapping file, invoke the engine. That's it. Write a mapping file, run the engine. And yeah, we're a long way from the mapping file now, I guess. But are there any mapping file writers left in the audience? Oh, we're a rare breed now. But there's a few of us. Get off my lawn! But when you can completely configure your engine with a single text file, that makes it easy to integrate that engine into a larger system. So the very first web program I wrote back in 1997 when I was running a consulting company was a web application that allowed map makers in our department to select a list of map sheets and a list of layers they wanted and output a single microstation file they could use to build a map product on. All the application did was take the list of map sheets and layers from web form, spit out a mapping file, and invoke the FME on it. There was no need to learn C++ APIs, no need to learn complex data exchange protocols. The FME's declarative model made integration a trivial issue. I also learned Perl in that project. More learnings. And later on, the FME gave me a reason to learn Tcl, to do coordinate manipulation during a transformation. Thanks, guys. And to learn SQL, which was very useful, another declarative language to hook FME up to departmental databases. More learnings. And each learning made me a little more powerful as a technologist. And each learning opened the doors to new learnings, like learning SQL in databases. I saw what a great integration point a database is, a kind of a format-neutral place in the middle of the system where all kinds of languages can access it easily. It was so useful that it made me wonder, I wonder if it's possible to put GIS data in there. This was not possible with the database I was working at the time. And so in early 2001, our company started experimenting with putting GIS data in the database. We tried simple stuff like blobs and relational schemas. And then eventually we tried using type extension in PostgreSQL. And it turned out that yes, it was possible. PostGIS was the proof of that possibility. It was both really fast at answering GIS questions and really convenient for storing GIS data. So since I have a broad geospatial cross-section here, I'm interested to know how many of you heard of PostGIS? Oh, yeah. How many of you use PostGIS? So gratifying. You don't think this is going to happen, like as Dale and Don in their basement. You don't think this is going to happen when you start. But incredible things happen. So for those of you who are new to this, PostGIS is a spatial extension for the open source enterprise database PostgreSQL. It supports all the ISO, SQL, and MEM types. It has an auto-tuned R-tree spatial index, query planner integration, high-performance support for common spatial predicate tests. It's got a geocoder, a routing package add-on, support for raster data and analysis in the database, and support for LiDAR data and analysis in the database. So in terms of features and performance, if you want a product analog, it's comparable to Oracle Spatial. I don't need a product analog anymore. Everyone knows PostGIS. PostGIS is to PostgreSQL, as Oracle Spatial is to Oracle, as bacon is to a cheeseburger, right? It's part of a larger whole, but it makes it so much better and tastier. So the first release of PostGIS was in May of 2001. It included the basic types and just a handful of functions, but nonetheless, people started using it almost immediately. The city of Boston, Fulton County, Georgia, were the first PostGIS users within a couple years of release. It's been over a decade now, and as we see, using PostGIS is about as cutting edge as using Linux, which is to say, not very cutting edge at all. Corporate users, including the Weather Network, that's WSI, Google, Infoterra, the New York Times uses PostGIS underneath their mapping sites. Government users, EGN was one of the first really big government organizations, the French National Mapping Agency, but now we've got state and local as well, Quebec, City of St. Paul, NOAA in the US federal government. So big and small, corporate and government, lots of folks are using PostGIS these days. As PostGIS moves from the margins to the center, the kind of software that supported it has also changed. The very first software to support a PostGIS database was MapServer, the open source mapping engine, and it supported PostGIS because we wrote the connector. But other open source projects adopted PostGIS very quickly as a data source, and it became the default data source. So when QGIS was launched, it supported just two formats, shapefiles and PostGIS. And so all these corporations and governments are now using PostGIS. It's just a standard tool now. But back then, in 2003, how could we tell if it was catching on? And we could tell by watching for market demand for PostGIS support in third-party software. So the first release, PostGIS, May 2001. The first reference to FME on the PostGIS users list was on July 27th, 2001. So already in our sights. In January of 2002, my business partner wrote to Dale at SAFE and told him about PostGIS and wondered if SAFE would support it. And at that point, we're already using PostGIS in production for data management, actually working for Customer Zero, Mark Sondheim at Geographic Data BC, and we were already FME users. So having full FME support for PostGIS would have been very handy. And Dale replied, in terms of PostGIS and FME, my hunch is that there is not a compelling commercial reason for SAFE to do this. Ow! Ow! Cut to the quick. So we know when we're relevant in the marketplace, it's when folks like SAFE see a compelling commercial reason to support us. And that didn't happen, actually, for FME right away, but it did in the end. In the spring of 2003, SAFE started PostGIS development, and that year FME became the first proprietary third-party software to support PostGIS as a data source. And fortunately, it's not the last. First, we picked up support from smaller GIS platforms that use niche differentiators like PostGIS support to appeal to the market. But by the end, every major GIS vendor ended up supporting PostGIS as a data source. They'd all found their compelling commercial reason to support PostGIS. Their customers demanded it, right? So working with FME taught me useful things like SQL and Tickle, maybe not so useful, and software integration. Similarly, working on PostGIS as an open source project has been professionally formative. First, learning the tools of open source to support the project. I learned the GNU tool chain and build tools to organize to support the project, to organize the code. I learned DocBook documentation for the first manual. I learned C and C++ for core development. I learned CVS and SVN, and then Git, God help me, revision control systems, so I could collaborate with remote developers. So I found that just doing open source has been an excellent driver of more learnings. It's made me learn more powerful tools and made me a more powerful technologist. And in fact, I found open source so interesting, I've made it into a career. I work on software you can download and you can modify and you can give to others without restriction. And perhaps for someone who gives away his work for free, I look startlingly well fed. But actually, I don't give my work away for free. I give my software away, and that tends to generate lots of work supporting the software. And customers of proprietary software, they've gotten used to the idea that paying money, the idea that you pay money for access to the bits, and that's the only viable model for a software business. But it's not. It's just one popular model where the value is in access to the bits. But I work for a company, Boundless, that lives in a world of geospatial open source. The bits are free. But we provide training on our products, and we provide consulting on deployments and scaling, and we provide support for organizations deploying the projects, insurance for when things go wrong, assurance that the software will continue to develop, and we keep project experts like me on staff so we can sell R&D and direct software development. We bundle it all together and build best-of-breed open source into a single package, and we provide special cloud and cluster-ready packages of our software. There's lots of things that a software company can sell other than the software itself. So here's a fun question, since we're at the FME UC, and Dale and Don are here. What would Safe Software be like if the FME were open source? Right? What would they sell? Where could they add value to the core product? What kind of business models could they use? The simplest model is just selling access to expertise, right? You want a new format, hire us to add one. That's an okay model. But as actually mentioned at the opening, it doesn't generate much revenue. So Safe Software would probably still be Dale and Don in the basement, right? And you can kind of see the end product of that model by examining the open source OGR to OGR tool, which has support for a decent number of formats, but has all the usability of a Soyuz space capsule. So how about another model? What about something more nuanced? Suppose the FME core was open source, but SAFE selectively sold access to certain format reader writers or factories. The core is open, the add-ons are not. There's a potential model. Maybe I'm seeing Dale's not quite buying that one yet. No, not good enough. Not compelling. My favorite imaginary open source FME scenario is one where the core is all open source. And you can write your mapping files, because everyone likes writing mapping files, and you can run them on the command line to your heart's content, but the fancy graphical workbench, that's packaged as a proprietary add-on. So you can have your FME in hardcore open source form, but if you want it the really easy way, you got to pay some money. So the engine being open, fancy interface, not open. So that was fun, but imaginary, at least for the FME. For open source software, though, business models like these are driving the development of all kinds of interesting software. And because it's easy to tinker with, open source provides all kinds of opportunities to learn new things, to expand your horizons, to do your learnings. And there's so many open source geospatial tools out there which you can add to your skill set. PostGIS I've mentioned, and manipulating and querying data in SQL is a wonderful skill to have, since it also applies to other databases, like Oracle and SQL Server. GeoServer and MapServer are really powerful web services engines for generating maps and features on the fly over the web. TileMill, very handy tool for generating cartographically attractive tile sets. Base maps. QGIS, a really powerful desktop GIS that not only provides a great multi-platform editing and map-making tool, but also integrates amazing algorithms from the GRASS GIS and Saga GIS and the Orfeo image processing toolbox. And then there's some great command line utilities for manipulating data. There's OGR for vector formats and projections. There's GDAL for raster formats and reprojections, and PDAL for LiDAR data. And the best part is they're all built with integration in mind, so you don't have to give up your existing tooling to use them. And they're a lot like FME in that regard. Open source tools play well with others. Open source tools are built with an engineering mindset, which explains both their positive attributes, flexibility, integration, modularity, and their negative attributes, the half-hearted attempts at usability, the tendency to provide an infinite number of configuration options. The open source mindset also places a high premium on reusability. One of the reasons that we prize open source is it allows us to reach into software and extract the useful bits to reuse elsewhere. Reinventing wheels is not a virtue for open source developers. We don't need to own all the intellectual property, so we reuse the bits that we need and build from there. Now, before writing this talk, I downloaded an evaluation copy of the FME, and I unzipped it, and I rooted around in the application folder, and I found the following libraries, open source libraries in there. I found XML libraries, I found format support libraries, GDAL for rasters, OGR for vectors. I found computational geometry libraries, CGAL and GEOS, data format libraries for MapInfo, NetCDF, SQLite, image format libraries for PNG and TIFF, a reprojection library, Proj4, a language library for TCL, and a rendering library, Mapnik, for outputting cartography. So, hey, the FME is already open source. Chock full of open source. Like any sensible modern software development organization, Safe Software is avoiding reinventing wheels. And they're not spending their development time on places that things have already been done. They're spending their time on places they can actually add value. There's no value in writing XML handling and image format support, even map rendering logic anymore, so they don't. There's value in bundling it all together and providing a nice user interface, a visual ETL workflow. The FME developers have clearly been out learning what options are available so they can avoid reinventing wheels, doing their own learnings. The FME helped kickstart my early learnings about GIS, and it gave me a good grounding in integrating multiple tools to solve problems. But that was a much simpler time. And the FME has grown a lot since then, since 1996. We just found a cartography rendering library hangout inside it. It's got 2 imperative programming languages, Tcl and Python, embedded in it now. It has its own filtering systems, its own overlay system, geometry creation, tin creation, rasterization engines, and more. It's a really good product. It's a really complete product. And that can be dangerous because you can solve so many problems without leaving the comfortable zone of the FME. Why would you bother to learn anything new? And I've seen the same thing in the world of spatial SQL. PostGIS users are writing incredible, complex spatial computation routines using PL/PGSQL and SQL, and that's simultaneously impressive and depressing. On the one hand, it's impressive, right? They are accomplishing amazing things. On the other hand, it's depressing in that they're doing it in this very narrow domain language, and the code ends up being really hard to read and debug and reuse. If they wrote their functions native to PostGIS in C, it would be easier to read, easier to reuse, easier to maintain. So these expert PostGIS users, they're trapped. They're trapped by their expertise. Learning a new programming tool like C means going back to basics before building up new expertise. They don't want to do the learnings. Really good tools can trap you intellectually. You have to keep up with the learnings to avoid it. Really good tools can also trap you another way. The open source community around Java is long-standing. Java was born at the dawn of the open source explosion, and it grew a vibrant community of tool makers right from the start. And back when Sun owned the Java language outright, and the early Java open source community was growing up, the godfather of open source, Richard Stallman, warned about what he called the Java trap. Basically, if you build open tools on a closed platform, you run the risk of losing the platform, and with it all your hard-won tools. The same critique applies to knowledge built using any platform you don't have the right to redistribute. The knowledge can only be spread as far as the platform. There was a teacher in Washington State University. He recently posted a blog about his decision to switch his Intro to GIS course over from ArcGIS completely to QGIS. And he said, I appreciate open source, but I also see the value in proprietary software. However, more than half the students in my intro class don't take any more GIS classes when they're at WSU. I think it would be valuable to them to learn how to use a GIS that is not going to expire on them or disappear when they upgrade their computers. No matter how comfortable we get with our tools, it's important to remember they might not always be with us. We have to do the learnings. I might not always have a spatial SQL database handy. You might not always have the FME handy. Ismail might not always have ArcGIS handy. We define our own limitations by what we choose to learn. We define our organizational limitations by the freedom and encouragement we give our employees to learn new things. FME can be a great starting point, but don't stop there. Right? Learn that data is a liquid, not a solid. Learn about talking to databases with SQL Executor, and then learn about writing your own SQL to answer complex queries. Learn about imperative programming using the Python caller, and then expand that knowledge from FME to ArcGIS or to open source Python frameworks. Learn about web services and hook up FME to GeoServer and MapServer and ArcGIS Server. Learn about cartography with TileMill, build some web pages, and bring your cartographic knowledge back to FME and the MapNIC rasterizer. But most importantly, learn something new or something hard. Learn something uncomfortable. Do your learnings. Thank you very much.